Good morning, everyone. And today we'll discuss about physical pharmaceutics second subject. So welcome you all. In this subject, we learn about colloidal dispersion, rheology, core dispersion, micromeritics, drug stability. So physical pharmaceutics. Pharmaceutics is a branch of science that deals with study of compounding and dispensing of dosage form or preparations of dosage form. Pharmaceutics, a branch which deals with which formulate dosage form physical properties. So manufacturing of dosage form, the physical properties as well as chemical properties is required for stable dosage form. So in this is a very important subject, physical pharmaceutics. Second, colloidal dispersion. So dispersion, it is a two-phase system. Colloidal dispersion are two-phase system, or it is a biphasic system in which one solid is dispersed in a liquid medium. Core dispersion, example, that is suspension and emulsion. That is a size difference. Colloidal dispersion and core dispersion, there is a basically difference in size. Colloidal dispersion we cannot see in naked eyes, but core dispersion of their dispersal particle size will seen in naked size. That is a core dispersion. Example, suspension, emulsion. Rheology. Rheology is a branch of science that deals with study of flow of liquid and deformation of solid. Micromeritics deals with smaller particle size. So smaller the particle size, greater the surface area and greater the pharmacological actions. Drug stability. So this is depend upon stability of dosage form. Physical, chemical, microbiological and therapeutic. Those dosage form fulfill this criteria, that is drug dosage form will stable. So drug stability, this five chapters we'll learn about in that one by one. Colloidal dispersion, those are polyphasic system, means many. One or more, poly means many, phasic system means two phase or more than two phase. That is a colloidal dispersion are polyphasic system. Classification based on state of matter. They are categorized in two categories: dispersion medium and dispersion phase, based on interaction between colloidal phase, lyophilic, lyophobic, and association. Lyophilic, lyophobic, and association co-adsorption. Separation phases. In two phases, one rich in colloidal particles and other more dilute phase, leads to phase separation and increase the concentration of colloidal phase. Properties of colloidal: kinetics, optical and electrical properties. Characteristics: particle size, surface charge, particle shape, surface area. Smaller the particle size, greater the surface area and greater the pharmacological actions. Gold number, it can measure the protective power of colloid, specifically its ability to prevent coagulation of golds, means two or more particles coagulate each other or gather put together. This can be prevented by gold number, means adding the electrolytes. A smaller gold number indicate higher protective power of lyophilic colloids. So colloidal dispersion, it may be defined as those polyphasic system where at least one dimension of the disperser phase measure between 1 nanometer to 1 micrometer. Colloidal dispersion are those polyphasic system, is two phase system. One dimension of the disperser phase measure between 1 nanometer to 1 micrometer. Classification: dispersion medium, molecular dispersion, size range less than 1 nanometer, molecular, smaller the size. Colloidal dispersion, size range 1 nanometer to 0.5 micrometer size, and core dispersion greater than 0.5 micrometer. This size you can remember, asked by competitive examinations. Molecular dispersion less than 1 nanometer, colloidal dispersion 1 nanometer to 0.5 micrometer, and core dispersion greater than 0.5 micrometer. Classification of colloid based on the charge containing positive and negative, based on the states solid, liquid and gas, and based on the lipophilicity, lyophilic, association and lyophobic, means water hating, water loving and association, both lipophilic as well as hydrophilic. Next, another association: anionic, cationic, non-anionic, and amphilytics. Both natures. Anionics, cationic. Anionic means negative charge. Cationic means positive charge. Non-anionic means no charge, and amphilytic means both charge. Dispersive phase characterization: size, shape, surface area, surface charge. Properties of colloids: optical properties, light microscopy, ultramicroscopy, electron microscopy, and kinetic properties in the diffusion, viscosity, and electrical properties, electrophoresis. So optical, kinetic, and electrical properties. Optical properties: Tyndall effect, colloidal scatter light, making the path of light beam visible. Transparency: colloid appears cloudy or translucent due to the scattering of light. Kinetic properties: Brownian motion, random motion due to the collision with the solvent molecule. Sedimentation: colloidal particles do not settle under the gravity unlike the particles. Zeta potential, electrical properties. In that zeta potential, the potential difference between the surface of colloidal particles and the bulk liquid, which determine stability. Electrophoresis: movement of colloidal particles under an electric field due to their charge. Next point, that is effect of electrolyte, coadsorption, peptidation, and protective actions. Electrolytes, ions in solution, can affect colloidal stability. Electrolytes means sodium, calcium, potassium, that is electrolytes. Ions can affect the colloidal stability, means either stability decrease or increase. High electrolyte concentration can cause coagulation or fluctuations. Coadsorption, it is also called phase separation. Coadsorb means this phenomena will occur also manufacturing of microencapsulation. Separation of colloidal system into two phases, one rich in colloidal particles and other are more dilute phase, leads to phase separation and increase the concentration of colloidal phase. Next one, that is peptidation. Coadsorption means separation of colloidal system into two phases, one rich in colloidal particles and other a more dilute phase, leads to phase separation and increase the concentration of colloidal phase. So colloidal system, basically it is a two phase system, one that is a particle dispersal and other is solvent. So what happens in two phase, one rich in colloidal particles, more colloidal particles, other more dilute phase, leads to phase separation. Next one, that is peptidation, the process of breaking up aggregate of particle into smaller stable colloidal particles. Means those particles gather together, that particle will breaking up aggregates of particle into smaller stable colloidal particles known as peptidation or peptidizing agent, increasing the stability by dispersing aggregating particles. Protective action, some of the colloid like proteins protect other colloidal system from aggregations. So gold number prevent coagulation by maintaining stable dispersion. A lower gold number indicate higher protective lower power and a higher gold number indicate lower protective power. So colloidal dispersion, those polyphasic system where at least one dimension of dispersive phase measure between 1 nanometer to 1 micrometer. Molecular dispersion, particle size less than 1 nanometer, particle size between 1 nanometer to 0.5. A molecular dispersion example, glucose in water. Colloidal dispersion example, that is jelly, butter and milk. And coarse dispersion, that is fine sand in water. For example, suspension and emulsion also comes under coarse dispersion. Particle size influence of pharmacological actions, means higher the particle size, lower the pharmacological actions. Smaller the particle size, greater the surface area and greater the pharmacological actions. Optical property help to know the size, shape. Kinetic property, it help to know the about the motion of particle. And electrical property, these properties help to know about charge on the surface of colloids. Dispersion difference in that is property lyophilic colloids, most organic molecule, lyophobic, largely inorganic particles, and aggregation of surfactant association colloids. Next point, that is rheology. Rheology is the branch of science that deals with study of flow of liquid and deformation of solid under stress. Rheo means flow and logos means science. Types of flow: non-Newtonian flow, Newtonian flow. Non-Newtonian flow again classified, that is plastic flow, pseudoplastic flow, and dilatant flow. Newtonian system: those material which follow the Newtonian law of flow are called as Newtonian flow. Newtonian law, it said that the shear stress is directly proportional to the rate of shear strain. So those liquid which follow the Newtonian flow, that is called Newtonian flow, and those not follow the Newtonian flow, that is called non-Newtonian flow. Kinematic viscosity, it is the ratio of viscosity of fluid to its density. The unit of kinematic viscosity is Stokes and centistokes. Rheology is a science that deals with study of flow of liquid and deformation of solid. Application of rheology, that is standards of liquids, manufacturing of dosage form like gels, cream, ointments, handling of drugs from administration, quality control tools for produce evaluation. Viscosity improve substance. So this is the applications of rheology, means standards of liquids, manufacturing of dosage form, handling of drugs for administration, quality control tools for product evaluation, viscosity improving. So viscosity means thickness, flow properties of simple liquid is expressed in terms of viscosity. Viscosity means viscous substance. Different type of viscometers utilized for determination of viscosity of gel, cream. So different type of viscometer, that is Brookfield viscometer, cone and plate viscometer, Brookfield cone and plate, cup and bob, single point at a single rate of shear, Ostwald viscometer, foreign sphere viscometer. So these are different type of viscometers. Newtonian flow and non-Newtonian flow, which follow the Newtonian law of flow. Example, that is castor oil, water, olive oil, methyl alcohol. Non-Newtonian flow in that fluid which does not follow the Newtonian law of flow. Plastic flow, shear stress, flocculated substance. Pseudoplastic flow, shear thinning occurs. And dilatant flow, deflocculated suspension. Thixotropy is a time-dependent property, isothermal and slow recovery on standing materials of consistency through the shear. Positive thixotropy, gel, sol, gel, means when applying the pressure, that is convert gel into sol, then removing the pressure, it comes under again gel. That is negative thixotropy, sol, gel, sol. So important, that is viscosity. Rheology's importance, that is viscosity determination, formulations of proper consistency, maintain the consistency, quality, stability, and flow. So that is the importance of rheology: viscosity, proper formulations, consistency maintain, quality maintain, stability maintain, as well as flow maintain. Newtonian system, those materials which follow the Newtonian law of flow are called as Newtonian flow. Newtonian law that said that the shear stress is directly proportional to the rate of shear strain. Non-Newtonian system, non-Newtonian flow are those which does not follow the Newtonian law of flow. Plastic flow, those material substances which follow the plastic flow are also called Bingham bodies. In this flow, we apply the shear stress. Initially, there are no change in shear strain until the shear stress reaches yield value. In this flow, apply the shear stress. Initially, there is no change, but after some time, there is a change until the shear stress reaches yield value. After yield value, they follow the Newton law of flow. Example, flocculated suspension, suspension of zinc oxide in mineral oil. Stereoplastic flow exhibit polymer. It is also called as shear. Viscosity decreases, we increase the shear stress. Example, polymer gum. Dilute flow, the material return to its original state after removing the force, deflocculated suspension. Next point we'll discuss, that is elastic deformation and plastic deformation. Elastic means removing the force, they comes on the original place, but plastic deformation, they cannot be changed. Elastic deformation, it is a reversible process. Material return to its original shape. Example, metal, rubber, and polymer. But plastic reverse irreversible process, material cannot come in original shape. Example, plastic. Revo means flow and logos means science. Deformation measures the change of matter of shape and volume. Next point we'll discuss about core dispersion. Coarse means that is greater than we can the particle size naked eyes. Core dispersion is a heterogeneous dispersion system in which the size of dispersed particle ranges from 1 nanometer to 100, means greater than 0.5 micrometer size. Core dispersion. These particles can be seen in naked eyes. Suspension are biphasic liquidosis form in which solid is dispersed in a liquid medium. Formulation of flocculated and deflocculated suspension. Vehicle required, weighting of particles, use of controlled flocculations, flocculation structured vehicle. This formulation of suspension we required a need, that is a vehicle solvent as well as weighting agent, excipients, coloring agents, antioxidants, preservatives, as well as drugs. Core dispersion method, that is preparation, that is in emulsion we think about method, that is dry gum method, wet gum method, and bottle method. Emulsion also biphasic liquidosis form of two immiscible, one liquid is dispersive phase and another liquid is dispersion medium. Types, that is O by W emulsion, W by O emulsion, and multiple type emulsion, that is O by W by O, W by O by W, and that is micro emulsion. Factors affecting on emulsion stability, that is particle size, particle distribution, viscosity, phase volume ratio, densities of phases, charge of electrical double layer, temperature fluctuations. Suspension are biphasic liquidosis form in which solid is dispersed in a liquid medium. Suspension stability, choice solvent, mass test, but those precision cannot be maintained. Deflocculated and flocculated suspension. Deflocculated suspension, particle settles independently and separately. Rate of sedimentation is high. Flocculated, rate of sedimentation is slow or low. Particle settles and floccles. Biodegradability is high. Biodegradability is less. Sediment is easily redispersed. Hard cake cannot be redispersed. Stability of emulsion. Stable emulsion and much globules retains their size as well as remain uniformly distributed throughout the continuous. Some instability occurs during the storage and formulation of emulsion, that is creaming, coalescence, breaking, flocculation, phase inversion, physical and chemical properties. Micromagnetics. Derived properties: true density, bulk density and porosity. Flow properties: angle of repose. Fundamental properties: particle size, shape and charge. powder size, surface area, adsorption method, and air permeability method. Particle size determination method, that is sieving method, microscopic method, sedimentation method, counter method, DSC differential scanning colorimetry method, SEM and TEM. Microemulsion are clear stable system which is droplet size between 10 to 100 nanometer. The hydrophilic lipophilic balance is used to select the right emulsifier for O by W or W by emulsion based on their affinity for water or oil. The HLB scale ranges from 1 or more lipophilic, means one starting range that is more lipophilic and last that is more hydrophilic. Applications next, that is this is a part discussed about, that is third unit, third topic core discussion. Some next discuss, that is fourth topic, that is micromeritics. Pharmaceutical formulation, particle size, surface area, and flow properties directly impact of drug bioavailability and processing. In food industry, particle size and packaging properties affect texture, taste, and product stability. In material science, micromeritics play a role in designing catalysts and other fine powders for specific functions. So micromeritics involves study of science and technology of small particles. Micromeritics involves study of science and technology of small particles and order of few micrometer size. Particle is normally denoted in micrometer. So important, the size and surface area of particle affect the physical and physicochemical properties of drug. Means smaller the particle size, greater the surface area, and greater the pharmacological actions. Absorption means greater the surface area, greater the absorption, and greater the pharmacological action. That is opposite also. Particle size higher, smaller the surface area, smaller the absorption, and less the bioavailability. Particle number, it is defined as number of particles per unit weight. Particle shape, the shape of affect the flow and packaging properties of powder. Spherical particle is fully characterized by its diameter. A mean particle size is measure the average of the particles. Particle size and distribution. Size distribution important because they use the possible to have two samples with the same average diameter but different distribution. Method determining surface area. Surface area of powder can be calculated using particle size data method. Air permeability method, and first that is adsorption method. First is adsorption method and second one that is air permeability method. Next one that is derived properties of powder. Porosity influence the dissolution of drug. Bulk density, flow properties. Porosity also known as voids, void volume or bulk volume. Packaging arrangement, the arrangement of particles powders influence the volume occupied in flow properties. And last chapter, that is drug stability. So first, reasons of instability: chemical reactions, hydrolysis, oxidation, and miscellaneous. Physical degradation, loss of volatile content, loss of water, absorption of water, crystal growth, polymorphism. Guidelines: be established study will carry out, that is ICH, International Conference of Harmonizations, and World Health Organizations. Storage condition, that is cold place, 2 to 8 degrees Celsius. Cool place, that is 8 to 15 degrees Celsius. Room temperature 25 degrees Celsius. It is a temperature mentioned in different pharmacopoeias. Storage method: well close the container, protect from light, store in cool and dry place, stability testing, accelerated stability study testing, shelf-life prediction, average addition, photostability, preventive measures. Factor influencing chemical, that is solvent, pH, buffer, ionic strength, dielectric constant. Chemical reaction kinetics, types of reaction, order, zero order, apparent zero order, first order, and pseudo first order. So drug stability means the ability of pharmaceutical dosage form to maintain the physical, chemical, therapeutic, and microbial properties during the time of storage uses by the patient. It's measured by the rate of changes that take place in the pharmaceutical dosage form. Drug stability means when we prepare dosage form right from manufacturing to right for patient delivery or patient administration, that drug is stable. That is the drug is stable. The ability of pharmaceutical dosage form to maintain the physical, chemical, therapeutic, and microbial properties during the time of storage and uses by the patient. It measures the rate of change that takes place in the pharmaceutical dosage form. Factor affecting of drug stability, that is pH, buffer, isotonic strength, solvent, dielectric constant, temperature, and solvent. Reaction orders, determination of reaction order by graphic method, substitution method, and half-life method. Reaction order is the sum of the exponent of the concentration terms in the rate equation of chemical reaction. It indicates how the rate of reaction depends on the concentration of a reactant. Zero order kinetics, the rate of drug degradation remains constant over the regards of the drug concentration. Means it follows the zero order kinetics, means controlled drug delivery system. The concentration does not change its pharmacological action, means either increase the concentration or either decrease the concentration. The drug release is constant. Zero order kinetics, the rate of drug degradation remains constant over the time, that is called as zero order kinetics. This means the drug is eliminated at a fixed amount per unit time independent of the initial concentration. First order kinetics, that the rate of drug degradation is directly proportional to the concentration of reactant drug. Does it depend upon increase the concentration, increase the excretion rate, means it is depend upon a concentration. First order reaction, the rate of drug degradation is directly proportional to the concentration of a reactant. Next, second order kinetics. Second order kinetics involve the biomolecular reaction, whereas the rate of degradation is dependent on the interaction between two molecules. The reaction occurs when two reactant molecules come together to undergo chemical transformation. So zero order does not depend upon concentration. First order depend upon concentration, and second order two reactants depend upon. Stabilization of medicinal agent. Pharmaceutical decompositions can occur due to the hydrolysis, oxidation, isomerizations, and photolysis. This process may impact stability, drug, liquid, solid, or semi-solid dosage form. Accelerated stability testing. This testing is conducted under high stress condition to predict the drug shelf life and assess its long-term stability. Prevention of photolytic degradation. Formulation strategy. Use of UV absorb, addition of antioxidant. Second, packaging strategy. Use of opaque containers, applications of UV protection coating, use of secondary packaging. Third, storage and handling. Control light exposure and proper labeling. Reaction kinetics, study of rate of which reactions occurs and the factors that affect them. Zero order, independent of concentration. Zero order reaction, where initial concentration appears constant because of the excess reactant but effectively follows zero order kinetics. Physical and chemical factors affect on degradation. Temperature, higher temperature typically increase the rate of degradation due to the increased molecular motion and energy. Storage condition, insulin required for refrigeration to slow degradation. Solvent, the choice of solvent can affect the reactions rate and stability of drug, aqueous or non-aqueous. Solution for drug formulations, solubility of hydrophobic drugs. Ionic strength, the concentration of ions in a solution can influence the rate of degradation, particularly in ionic reactions. Aqueous solution with high ionic strength might stabilize or destabilize drug depending on their chemistry. Means solvent, when we choose the solvent that is hydrophilic, water loving, that some drugs are not soluble in water, that's why the stability problems occurs. Ionic strength similar, like means hydrophilic drugs that can be less solubility. A dielectric constant, the ability of solvent dissolved in ionic compound affect the reaction rate. Polar solvent, high dielectric constant are used to dissolve in ionic drug. Unit of basic react determination of reaction. Accelerated stability testing means higher the temperature. Predict the stability or shelf life. Testing of drug stability under the X aggregated condition means high temperature, humidity to predict the shelf life. FDA, Food and Drug Administration, regulated testing for expiry dates of drug product. Photolytic degradation, degradation caused by the exposure of light leading to the breakdown of drug molecule. Sunlight exposure of drugs like nitroglycerin leads to photodegradation. Prevention of photolytic degradation, use of light protective packaging, antioxidant, or modifying the formulations of prevent degradations. Amber glass bottles or opaque packaging for sensitive drugs like phototoxic compounds. Means prevention of photolytic degradation, used by amber glass bottles. So key summary on drug stability reaction kinetics, that is factors affecting on degradation, that is temperature, solvent type, ionic strength, pH can significantly influence the stability. Stabilization methods, chemical stabilizers, antioxidants, packaging method, light protective containers. Accelerated stability, determine the expiry date, and photolytic degradation, exposure of light degradation drugs. So question asked in the physical pharmaceutics-II question paper, that is physical first question, write a classification of colloidal dispersion. So colloidal dispersion classification based upon particle size, means core dispersion, colloidal dispersion, and molecular dispersion. Enlist and explain the properties of suspension. Ideal properties of suspension: does not form a hard cake. Write a difference between order of reactions and molecularity of a reaction. Next, what is the zero order reaction? Zero order reaction does not depend upon concentration. Write pharmaceutical importance of particle size determination. So particle size determination, pharmaceutical importance for dosage form, bioavailability, especially a lyotropic series, differentiate plastic and elastic deformation. Plastic does not come original place, elastic comes original place after removing the force. A 10-mark question, that is compare shear thickening and shear thinning system with example, that is rheology questions. Discuss optical electrical properties of colloidal sol. Next, describe derived properties of powder. Next, write an integrated rate law equation, first order, second order reaction. 5 marks questions: protective and sensitization of colloids, air adsorption method, physical degradation, instability of lyophilic colloids, first order reaction, cup and bob viscometer, lyophilic and lyophobic colloids, capillary viscometer, emulsifying agent, rheology of suspension. Next, second question paper. First question, that is define zeta potential and write its pharmaceutical importance. B, that is differentiate microemulsion and emulsion. Define and write applications of multiple emulsion. Why high molecular reaction rate? Write difference between order of reaction and molecular of reaction. Define porosity and write its application. Write equation of elastic modules and explain parameters. Answer the following. Write a note on instability of preservation of emulsion. Describe particle size determination methods. Explain in detail formulation of suspension. Enumerate derived properties of powder. Next, write a short note of following: stability of lyophilic colloids, cone and plate viscometer, HLBN method, half-life and shelf-life, physical degradation, gold number, counter method, stability of emulsion, capillary viscometer. So hope this lecture will helpful for the semester examinations as well as competitive examinations. Key summary: will discuss about colloidal dispersion, rheology, core dispersion, drug stability, micromeritics. Hope it will be helpful for your examination. Thank you. See you in next lecture. Keep learning, keep growing.